Hello everyone, welcome back to the channel again in LeetCode series. Today we are going to solve LeetCode problem number 1512, number of good pairs. So, this is a simple but very interesting problem that teaches us how to move from brute force to an optimized solution. So, question is saying that we have given a array of integers nums and return the number of good pairs. So we will iterate throughout the array of integers nums, and then we will apply a condition where we will find nums of I is equal to nums of j, and then till I is less than j, and then if we find this condition, then we will return the number of good pairs. So step 1, we will go with brute force approach. So let's start with the brute force solution. The idea is straightforward. Check every possible pair in the array. So in this example you can see, if we iterate throughout this array, we will go to first 0 index, then one first index, second index, third index, fourth index, and then fifth index. Because the length of this array is 6, so we will go till fifth index. So at 0 index we will find elements as 1. At one index we will get 2. At second index we will get 3, and at third index we will again find a element which is equal to at 0 index. So this is a good pair. Here you can see the explanation in this problem. 0 and 3. At 0 index and 3 index we will find the nums of I equal to nums of z. So this is a good pair. Again, at fourth index we will again find a 1 as elements which is equal to 0 index. That means nums of I equal to nums of j. So here you can also see at 0 index and at 4 index. Again this is a good pair. And now at third index and fourth index also 1 1, this 1 1 also this is a good pair. And now at finally at second index and at 5 index, elements as a 3 is a good pair. So we will, if we apply brute force approach, we use two nested loops, and for each I and j we check if nums of I equal to nums of j. If they are equal, we found a good pair. This works fine, but time complexity is big O of n square because of two nested loops, and then which is not efficient for large inputs. Now we will go to optimize approach, step 2. Now let's optimize. Think about how many times each numbers appear in the array. If a number appears r times, the number of good pairs formed is r. Choose 2, which is k into k minus 1 upon 2. This is basically a formula. So the plan is count the frequency of each number, then apply this formula. This reduces the complexity of big O of n, which is much faster. Now we will see the time complexity. Brute force will go with big O of n square and with space g big O of 1. Optimized approach, which will take the time complexity of big O of n, which reduce from big O of n square to big O of n in this optimized approach, and it will take a space of big O of n, which is more than that brute force approach. Obviously the frequency map, we will use frequency map method here, and we will have to take care of some edge cases like first, if there is a empty array, then answer would be 0 because there will be no good pairs. because for one good pairs there must be two elements in that array must be present, so we will get good pairs, otherwise there will be no pairs formed and we will return answer 0. So this is first edge case. Now we will go to second edge case, single element. If single element is present then answer would must be 0 again. And third one, if all elements are same, then we will return maximum number of good pairs. And at last, if all elements are unique, there is no same elements repetition of elements, there is no duplicate elements, then we will return again answer 0, because if there is no duplicate elements then there will be no pair formed, good pairs form, because in this question you can see nums of I equal to nums of say, because if there is no duplicate elements there is no satisfaction of this condition will be applied, so we will must return 0. Now the point is what data structure we should use to optimize this approach and get a better result. So we will use here a hash map is best choice for counting frequency, because in hash map we will count the frequency of elements how many times it coming. um, Alternatively, if the ranges of number is small, we can also use simple array to store the that we will iterate throughout the array. Now, the point is how can we think or start solving this type of problem. When we think thinking process, how our brain will think, so always start with brute force. Try to start with brute force solution, then ask yourself how can I use repetition or frequency to optimize, because here we will use frequency map, hash map to optimize this. So you will have to think frequency counting is a natural step here. Okay. Now we will go through the code walkthrough. So here you can see, mm, now we will use an ordered map. So ordered underscore map. Now we will use integer comma int, and we will take a variable name, let's say frequency. Now we will take a integer like answer. If we will get nothing in our edge case we will return 0, so we will take answer is equal to 0, assuming just. Now we will take a for loop uh, with integer num. It will iterate throughout the nums. It will this num iterator will throughout the nums integer array. So we will take this for loop. Now we will answer plus is equal to frequency of num. Okay. Now now we will frequency plus frequency of num, sorry, will plus. Now finally we will return answer. Now let's check our test result. Let's wait, it is taking some time. So our test case is passed. Now the point is what learning we will take from this solution. So the key learning is whenever you need to count pairs based on equality frequency, count plus the formula k into k minus 1 upon 2 is very powerful. So the key point is begin with brute force approach, optimize with frequency counting, Remember the formula k into k minus 1 upon 2. Hashmap or array both work depending on constraints. For a small inputs, we will use simple array, and for large input, we will obviously use hashmap. So thank you for being here. We will meet in next video. Thanks for watching.